Hello, I'm Max Díaz Herrera. I'm represent making the IHM, and in this video I will summarize the PPAP process for the hydraulic piston root developed for JLG. My product is an hydraulic piston roof. Uh, the piston works to generate pressure inside the hydraulic cylinder. It carries seals which make a seal to prevent leakage of hydraulic fluid and goes together with the piston roof which will perform the stroke inside the cylinder. In my PSW, my per-submission warrant confirms that the part meets customer specs. In this project, we made a key material change. The previous supplier used aluminum, but we've upgraded to chrome-plated steel with a new supplier. This improved hardness, avoids deformation, and ensures better durability during cylinder operation. So you can see we have the reason for this submission, that it's supplier change and material change, and the submission level is level 3, and the responsible it's me, like as a position of receiving director. In my design records, how you can see in this slide, I show you my 3D product, my 3D design, and these include drawings and critical dimension used for the production and inspection. How you can see, this is my drawing with measurements to use in the production, and these views like frontal, lateral, and isometric view. In my material records, uh, we verified that the chrome steel met all required chemical and mechanical specs with traceable certifications. In my material information, I have raw material type. It's induction hardened and chrome plated with this specification. Surface coating is hard chrome plating, and my applicable standards it's ISO and ASTM. It's specified by customer. Uh, my material supplier is Ternium Mexico, and we have certificate of chemical composition, mechanical properties, hard chrome plating, thickness and adhesion, and head treatment certificate. The responsible person for material record is Karina Reyes in her position of quality responsible. And the process record uh, flow covers every manufacturing step, helping you identify risk and maintain consistency. Uh, we use a production volume of 1,000 lots per month in the plant location. It's in Puebla, Mexico, and the conversion is 1.0 in the date of July 3rd of 2025. That's my process flow and records. It's how you can see in this first part we have 6 steps, sorry, with all the features like process name, description, equipment, tools used, responsible, and record type. Uh, Now here are other 4 steps. Uh, it, it is painting, final quality detection, packing, and now conformance handling. In the rejection policy, we have 3 conditions, non-conforming parts are redirected to rework or molding process. If the defect rate exceeds 2% per lot, the entire lot is scrapped and reported. A rejection must be documented with traceability to operator, lot, and defect type. And we have applicable standards, how you can see in the 3 point. First, it's ISO 23125 and ISO 10791 turning and machining centers for CNC machining. We have the per ISO 14253 one for dimensional inspection and the ISO 8501 for the surface cleanliness and paint in line with customer specific, and the quality control plan aligning with AIAG PPAP requirements in the fourth edition. Uh, in this part, we analyze the real production data to calculate CPK and PPK. The process was shown to be both stable and capable. In the test results, uh, we test batch the lot number 50 and the test by quality responsibility and rest the scene engineer with micrometers and calipers to confirm all K dimensions. Results showed full compliance. So you can see we have the dimensional test with specification like the number 2 root diameter, it's 25 millimeters. The measured value is 25.02 millimeters with a more or minus 0.02 millimeters of tolerance in the resulted file, because it's the measured value, it's into the tolerance, so it's part of this dimensional test results. In the surface finish test, we have a rod body and thread section. We use an equipment like a surface profilometer, and the result in both is pass. Uh, Hardness test. The zone is rod shaft, surface, and thread end. We use the method Rockwell C, and the result is pass for the rod shaft and the fail for thread end. For the paint adhesion test, if it's applicable in all uh, part it's applicable, we have the test method cross cut test, and the result is pass, and the observation is no peeling or flaking. Conclusion: the press rate is 80%, the defect rate is 20%, 2 out of 10 items failed, but it's okay. So we have to process capability study. In this part, we analyze real production data to calculate CPK and PPK. The process was shown to be both stable and capable. We use the instrument like micrometer and the specification limits like 34 that 95 millimeters, and the nominal 35 millimeters, and USL it's 35.05 millimeters, and the sample size is 1000 pieces, sorry, 100 pieces, and the standard deviation is 0.01817 millimeters with a CP as 0.918 and CPK is 0.879. That's my illustration. It's a process capability histogram, with the information that I show you before, and we pass to uh, FMAA and DFMAA. The first one is the failure mode and effects analysis. We have first four steps with the process function, and I add the SOD matrix, who you can see in this part. And here I talk about the SOD rating criteria. The S is for severity, and the 1 is no effect, 5 is moderate inconvenience of slight performance loss, and 10 is hard use without warning, safety critical. In the occurrence, it's the letter O. We have the first one, it's failure unlikely, the 5 is occasional failure, and 10 is failure almost inevitable. In the letter D, we have the detection. 1 means certain detection with current controls, 5 moderately likely to detect, and 10 impossible to detect before failure. And my design for manufacturing and assembly, we have these things. For example, in the DFMA concern, we have the tolerance on a diameter to 26.5 millimeters, and the recommendations and observations. In the control plan, we have in this slide full process with the name of this process, control method, reaction plan, and method of measurement. And here we have other 5 steps with the same features that the before I show you, and it's everything. Um, it's everything for me. Thank you for attention. And the conclusion is that Machine DHM is successfully complete this PPK with a key material improvement, full documentation, and a reliable production process. Thank you for watching.